Good morning, dear student. In today's lecture, we will discuss the second important type of magnetic material, that is paramagnetic material or paramagnetism. In previous lecture, we already discussed the diamagnetic material or diamagnetism, in which we discuss that is uh, we discussed the plot of applied field strength versus magnetization. So in diamagnetic material, the magnetization is opposite to the direction of external magnetic field, and the magnetic susceptibility is constant when you plot a graph of magnetic susceptibility with temperature. So if you consider this paramagnetic material, so we are very much familiar with this paramagnetic material, that is the material having an unpaired electrons. So if you consider this paramagnetic material, in this material the atoms or ions have unpaired electrons. In this material, atoms or ions have unpaired electrons. So this is the basic difference between diamagnetic materials and paramagnetic material. In diamagnetic materials, all electrons are paired and there is no unpaired electrons, and therefore the net magnetic moment is zero due to the pairing of electron in case of diamagnetic material. But in this paramagnetic material, the atoms or ions have unpaired electrons in partially filled orbital. That means each atom in paramagnetic substances have a small net magnetic moment. So this is the first important point. In paramagnetic materials, atoms or ions have unpaired electrons, and uh, due to this unpaired electrons, these substances have small net magnetic moment. These substances, having small net magnetic moment, because we are very much familiar that the orbital motion and spin motion of electrons are the basis for the magnetic moment, and there is an unpaired electron in this paramagnetic material, and therefore these substances having small net magnetic moment. But there is no interaction between these atomic magnets. So the third important point is that we already discussed in diamagnetic material, that is it is a weak magnetization, because there is no interaction between atomic magnets. So in this case also, if you consider, no doubt they contain unpaired electron, but there is no interaction between these atomic magnet. There is a weak interaction, or there is a no interaction between these atomic magnets, because many electrons are pair and some electron is there, therefore there is no interaction. If both electrons are unpaired, then there is a slight interaction, but in this case some electrons get pairs and some electron is unpaired, so there is no strong interaction between this atomic magnet. But in presence of external magnetic field, but in presence of external magnetic field, there will be a partial alignment of this atomic magnet with magnetic field. So if you consider atomic magnets, they are considered as electrons. So electron, in this case, we consider this electrons as a small magnet or tiny magnets, and therefore in presence of external magnetic field, in presence of external magnetic field, in presence of external magnetic field, there will be a partial alignment. There will be a partial alignment of this atomic magnet of this atomic magnet. Means we know that these atomic magnets or these electrons have a random motion when we consider the material in absence of external magnetic field. So we already discussed the behavior of the electrons in case of in absence of external magnetic field and in presence of external magnetic field. So in absence of external magnetic fields, they have a random motion, but no doubt in this paramagnetic material there is an unpaired electron, and due to this, in presence of external magnetic field, there will be partial alignment of these atomic magnets. Means the direction, that is the direction of applied magnetic field strength and the direction of the electrons or this atomic magnet is same. Means the magnetic lines of force can easily pass from this material, and therefore the net magnetization is positive and the magnetic susceptibility is also positive. So if you consider the next point is that is the alignment, the partial alignment of this atomic magnet with magnetic field results into change in magnetic moment, that is no doubt there is already magnetic moments due to the unpaired electrons, but the magnetic moment, the net magnetic moment is increases, and due to this there is a positive magnetization due to the application of external magnetic field, positive magnetization and positive susceptibility and positive magnetic susceptibility. So the magnetic lines of force can easily pass from this material because due to the application of external magnetic field, there is a partial alignment. Means the direction of the atomic magnets, means the electrons and the external magnetic field is same, and therefore this atomic magnets or electron cannot oppose to the external magnetic field, and therefore the magnetic lines of force can easily pass from this material, and therefore the net magnetization is positive. So as we increases the applied external magnetic field strength, the magnetization is increases. So if we see the graphical representation for this paramagnetic material, and if we plot the graph of applied magnetic field strength versus magnetization, then we get such a kind of graph, that is a linear relationship between this magnetization and applied field strength. That is, as the applied field strength is increases, the magnetic susceptibility is also increases, and the slope which is equal to the magnetic susceptibility, because we know that m, which is equal to magnetic susceptibility into applied field strength, and the magnetic susceptibility, so in other words we can say that the magnetic susceptibility is greater than 0 for paramagnetic material. For diamagnetic material it is constant. So you should keep in mind the difference between diamagnetic and paramagnetic material. So the graphical representation indicate there is a linear relationship between applied magnetic field strength and magnetization. As applied field strength is increases, magnetization is also increases, and the magnetic susceptibility having a positive slope indicate the magnetic susceptibility is greater than 0 for paramagnetic material. But if you plot the graph of magnetic susceptibility with respect to temperature for paramagnetic material, then we get such a kind of graph is there, that is magnetic susceptibility. What it indicate? That the magnetic susceptibility, it is inversely proportional to the temperature. Magnetic susceptibility, it is inversely proportional to the temperature. Means if the temperature of paramagnetic substances is increases, then the alignment of atomic magnet will be disturbed. So you should keep in mind what this graph indicate. As the temperature of the paramagnetic material is increases, then the alignment of atomic magnets is disturbed. So whatever the alignment in external magnetic field, it is disturbed by the application of temperature. And therefore, if you consider, this means that the magnetic susceptibility depends on temperature, and the magnetic susceptibility is inversely proportional to the absolute temperature. So these two graphical representation for this paramagnetic material, that is magnetization versus applied field strength, and second, temperature versus magnetic susceptibility. In case of diamagnetic material, the magnetic susceptibility is constant with respect to temperature, but in case of paramagnetic material, the magnetic susceptibility is inversely proportional to the temperature. That is, as with increasing temperature, magnetic susceptibility decreases. So this is all about the paramagnetic or paramagnetism. In next lecture, we will discuss the ferromagnetic materials and the ferromagnetism. Thank you.